Problem 4, negative x squared plus 5 plus 15 equals 0. And you're just supposed to solve this. So if I need to solve it, I need to get x squared by itself. What do I do? I'm going to minus the 15 first. I could multiply, but that makes me have to do way more work than I need to right now. So I have negative x squared divided by 5 equals a negative 15. How do you get rid of that 5 that's in the denominator? You multiply both sides by 5. So then I have negative x squared equals negative 75. Okay. Then what do I do to get x squared by itself? Not yet. Because it's not x squared, it's negative x squared. So mathematically, I divide by negative 1. So that gives me x squared equals 75. So then I need to square root that. That's my next step, which you were saying that a second ago. So I square root both sides. That's going to give me, I'm out of space, x squared, x equals the positive and negative square root of 75. How do I simplify that?
15 and 5.
Okay, so I'm going to do this one using a factor tree. So I'm going to factor 75. That is 15 and 5, and 15 is 3 and 5. So really I end up with x equals the square root of 3 times 5 times 5. And if I'm factoring it out doing the prime factors, I'm looking for what they have pairs of. What do they have pairs of? 5. Okay. So if they have a pair of 5s, that means I'm going to have a 5 on the outside, and on the inside I'm going to have a square root of 3. And it is the positive and negative form of that, so my answer would be x equals positive and negative 5 times the square root of 3. So for problem 5, the very first thing I would do to solve it is I would distribute. 2 times 5 is 10, and then 2 times negative 5 would be a negative 10x squared equals 5. And then that's the problem that you solve. So to get the x squared by itself, I'm going to minus 10 from both sides. And I get negative 10x squared equals negative 5. Then what do? You divide by negative 10. And I get x equals positive 1/2. Oh, x squared, I'm sorry. Thank you. What do I do now? I square root it. So x equals the positive and negative square root of 1 over the square root of 2. So I'm going to go ahead and write those separately. What is the square root of 1? 1. So it's just going to be 1 on top. So I could really just, if I wanted to, go ahead and erase that square root symbol there. And then how do I get rid of, because I cannot have the square root of 2 in the denominator, how do I get rid of that? You multiply by what? Square root of 2 over 2. And that is called what? It starts with an R? Rationalizing. So I'm going to multiply the top and the bottom by the square root of 2. So 1 times the square root of 2 gives me square root of 2 on top. And on the bottom, square root of 2 times square root of 2 is really the square root of 4, which works out to just be 2. Give answers both exactly and approximately to the nearest tenth. When they say they want them exactly, that means that they want them using like square root symbols. Approximately means using decimals. And then you need to find the area of the rectangle is 54. So let's start with our rectangle. So we know that one side is x and the other side is 3x. So what is my area going to be? 3x times x, which is 3x squared. So that is the first thing we know, is that my area is actually 3x squared, but they just did all this math and told us that the area was actually 54. So what we know is that 3x squared has to equal 54. Looks like what? Okay. What do I do now? How do I solve this? I divide by 3. So then I get x squared equals, what is 54 divided by 3? 18. Okay, so what do you do now? You square root it. Okay, can I take the square root of 18? Like, actually, it's like a whole number? No. So we need, because it doesn't have a perfect square. Like, 18 is not a perfect square itself. But I can simplify it. Yes. All right, so we can simplify. We can simplify that a couple different ways. One thing that we can do is we can list out our perfect squares. So thinking about 18, it is 1 times 18, or 2 times 9, or 3 times 6. So of these numbers, which of those are perfect squares? The 9 is, and 1 is a perfect square. Which of those is the bigger one, though? The 9. So really, this square root of 18 becomes the square root of 2 times the square root of 9. What is the square root of 9? 3. So it's really 3 times the square root of 2, and it's the positive and the negative form of that. Now, we are finding the area of a rectangle, and like, we found out that x equals this number. This is not just some random number. We found out that x equals that number. What are we finding out if we're finding x? The height, yeah. So can my height be negative? No, so I'm really only focusing on my actual height of my rectangle is the 3 times the square root of 2. It's the positive version of that. So that is the actual form. To find the decimal form of that, we need to put that in the calculator, 3 times the square root of 2, and see what it gives us. It's actually going to give us a decimal, a real number, that we can, like, tangibly understand. 4.24? Okay, so that would be our height, would be 4.24. Then it wants us to find our width, because if you notice it did ask us for both. How do we find our width? What did it tell us that was? 3 times x, and what was x? Okay, so the width is going to be 3 times the square root of 2. So when I have this 3 times the square root of 2, what do I do with these two 3's? What do I do with my two 3's? What? Yes, what is 3 times 3? 9. So that would be my answer, would be 9 times the square root of 2, which in decimal form would be 12.72. So that would be my entire answer for that whole problem. So your instructions on problem 13 were to, it said to square, what did it say? Find the square of the imaginary number. So that means I need to take this imaginary number. How do I know it's an imaginary number? Has an I, and I need to square it. So if I'm squaring it, mathematically that means that I am multiplying it by itself. So I'm going to rewrite 2 of these, because I think it just, to give an understanding of what we need to do, it helps us to see it visually, that I am writing 2 of these. And then I can do my multiplication. So just looking at it, I have a negative I times a negative I. Well, what's a negative times a negative? Positive. Okay. So I end up with I squared, because I times I is I squared. Then if I multiply my square root of 2 over 2 times square root of 2 over 2, let's just start with my square root of 2. If I multiply my square root of 2 on top times my other square root of 2 on top, well, square root of 2 times square root of 2 is really the square root of 4, and the square root of 4 is actually 2. So I end up with 2 on top. And then I have the denominators, 2 times 2. What is 2 times 2? 4. So I end up with 4 in the bottom. Mathematically, what does I squared equal? Yes, it is negative 1. So this is really negative 1 times 2 over 4 is going to reduce to 1/2. And then a negative 1 times a 1/2 is going to give us negative 1/2. And that would be your final answer. Problem 28 says that Russell wants to calculate the amount of time it takes for a load of dirt to fall from a crane's clamshell bucket at a height of 16 feet to the bottom of a hole that is 32 feet deep. He sets up the following equation and tries to solve it. the way that it's set up and you look at how they've worked it out, they work it out correctly. There is nothing wrong with this. But let's talk about what this means, and this will help you answer the first part. Does Russell's answer make sense? So if you think about what's happening, you have a crane that is dropping dirt from the crane to the bottom of a hole. So realistically, is eventually the dirt going to end up in the bottom of the hole?
Yeah.
Okay, that logically makes sense. But they're ending up with an answer of positive negative square root of I. What that means is that there's no real solutions. So like graphically, if you have an imaginary number, that means that your graph never touches the x-axis. You don't have to draw that. But that's what imaginary answers mean, is that your graph never touches the x-axis. That means there's no solution, or in this case, that our dirt never actually reaches the bottom of the hole. But we know that the dirt really does reach the bottom of the hole. So the first question asked us, does his answer make sense? And what's the answer to that question?
No.
No, why not?
I don't know.
Yeah, the dirt has to reach the bottom of the hole at some point. So the second part says, if not, find and correct Russell's error. So let's look at this problem. I'm going to tell you that the error in the problem, because this was hard for me to identify, it took me about 15 seconds to read the problem and kind of figure out like what was wrong with it. I know, but I'm saying if it took me some time, like I really had to sit there and think about it, then I know it's going to take you time to sit there and think about it too. Okay? I'm going to tell you the answer has something to do with the numbers 16 and 32.
But they're divisible by?
Nope.
Not add together.
So the problem with this one is that this 32 should be a negative 32 because it's going into the hole that's like underground. It's going 32 feet below the ground. So thinking about the ground as the x-axis, you're 32 feet down, you're at negative 32. So if you work that problem out now, because not only do you have to find the error, you have to correct the error, which means you need to rework out the problem. So if you work that out with a negative 32, you are going to get a positive answer.